Welcome to qnawire.
Okay, this is question 5.80, elevator design. We're designing an elevator for a hospital, and we're told that the force exerted on a passenger by the floor of the elevator is not to exceed 1.6 times the passenger's weight. So the normal force here, which I'm calling N, this is the force exerted on the passenger by the floor of an elevator. And so the maximum force here that we want is 1.6 times M times G, where G is 9.8. We're then told that the elevator accelerates upward with constant acceleration for 3 meters and then slows down. And we're asked the maximum speed of the elevator. So if we think about this, the elevator is going to be accelerating over these 3 meters and then start to slow down. So the maximum speed will be right when it has traveled these 3 meters, since it'll be speeding up to that point and then start to slow down. So we're going to need to find the acceleration. So to do that, let's set up our typical Newton's second law equations. Sum of the forces equals mass times acceleration. So the forces in the y direction here, that's the only direction where we are considering forces. So we'll have the normal force pushing the passenger up from the floor of the elevator. Then we'll have the weight of the passenger pulling down, mg. And that will be equal to the mass times the acceleration. So we are told here, remember, that our maximum normal force that we want is 1.6 mg. So let's go ahead and just plug that in for our normal force. And we want to solve for the acceleration, so we can cancel out a factor of m in all of these terms. And here we'll end up with 1.6 g minus g. That's just going to be 0.6 times g. And when we plug in g is 9.8, we should get that the acceleration is 5.88 meters per second squared. So now we have the acceleration and we want to find the maximum speed. So we want to find the speed after it's been accelerating over these 3 meters. So to do that, we want to use our kinematic equations. Let's use this one. The final velocity squared is equal to the initial velocity squared plus 2 times a times the distance that it's traveled. Now it's starting at rest, so we can, our initial speed here is going to be 0, so we can get rid of this term. And now we have, we know that the acceleration is 5.88 and the distance is 3 meters. So we can just plug that in and then take the square root of both sides to solve for v, and that should give us v is 5 meters per second.